Now let's talk about limit. A limit is a point or level beyond which something does not or may not extend or pass. The notation for a limit is written and read as the limit of f of x as x approaches a is equal to L. L is the exact numerical value for our limit. F of x is the function provided, and the value of a here is the value specific domain. Now, for a function to have a limit, it must satisfy the following conditions. Number one, that f of x must exist at f of a, meaning when we substitute the value of a in our given function, f of a must exist. In our condition number 2, the limit of f of x as x approaches a must exist. Now, for a limit to exist in a given function, the left-hand limit and the right-hand limit must be equal. If not, then we could conclude that the limit does not exist. Now, for the third condition, the value of our a in our condition 1 must be equal to the value of the limit in our condition 2. If not, then the limit does not exist. Let's have our first example. We are asked to investigate the limit of f of x is equal to 2 as x approaches 5. So our f of x is a constant function. Now to determine if the limit is existing, we have to do the first condition. We have to find for f of a check f of a if it exists. So f of a is the same as f of 5, that is equal to 2. Therefore, f of a exists and it is equal to 2. Now, for our second condition, we have to determine the limit of the given function. So we know that our x is approaching 5, meaning from the right direction, as we approach as 5, we have probably 5.03, followed by 5.02 and 5.01, while on the left side or negative direction, as we approach as 5, we have 4.97, 4.98, and 4.99. Now let's check if into what number our f of x is approaching, and that would be the limit. So we have to check it in our left direction, negative direction, and the right direction, or a positive or our positive direction. So our function is f of x equal to 2. Now, if you're going to substitute 4.97 in our function, so that would become f of 4.97 equal to 2. Our 4.98 is also equal to 2, and our 4.99 is equal to 2, meaning these are all 2. And for our right side or positive direction, we have f of 5.01 is also equal to 2, and so on until f of 5.03 that is equal to 2. So meaning these are all 2. We could say that the limit of our f of x as x approaches 5 from a negative direction is equal to 2, while on the other side, which is the limit of f of x as x approaches 5 from a positive direction is also 2. We could see here that the limit in our left hand side and our right hand side are the same. They are both equal to 2. Therefore, limit exists and it is equal to 2. Now, for instance, that the limit of one of these sides, for example, the left side, the limit on our left side is not the same as the limit on our right side, then the limit does not exist. Now, in order for a function in order for a function to have a limit, the value of our f of a and the value of our limit of f of x as x approaches a must be equal. In this case, the value of f of a is equal to 2, and the value of our limit is also equal to 2. We can say now that the limit of 2 as x approaches 5 is equal to 2. Let us have another example. We are asked to determine the limit of the given function, which is 2x plus 3, a linear function, as x approaches 1. So we have to check first the value of f of a, which is the first condition that the function has a limit. The value of f of a is f of 1, meaning we have to substitute the value of 1 to our 2x plus 3. That's 2 times 1 plus 3, and that is 2 plus 3 equal to 5. Therefore, f of a exists and it is equal to 5. For the second condition, we have to determine the limit of the given function as x approaches 1. We know that x is approaching 1 and that the numbers from the right side approaching 1 are 1.03, 1.02, and 1.01. On the negative direction or the left side of 1, we have 0.97, 0.98, and 0.99. Now, we have to determine the values of f of x so that we could see to what number our f of x is approaching. So we have to evaluate f of x. So for the first value, we have 0.97. That would become 2 times 0.97 plus 3, which is our function here, is equal to 4.94. Now changing the value of x to 98 because it is approaching 1, we have 4.96. And then for 0.99, we have 4.98. Thus, we could see here that 4.94, 4.96, and 4.98 is approaching 5. We could say that the limit of the given function f of x as x approaches 1 from a negative direction is equal to 5. That is equal to 5. Now let's check the right direction or the positive direction. So we have 2 times 1.03 is 5.06, followed by 1.02 is 5.04, and followed by 1.01 is 5.02. As we can see here, our f of x as x approaching 1 is approaching 5 also. So we could say that the limit of the given function f of x as x approaches, as x approaches 5, approaching 1 from a positive direction or from the right side is equal to 5. As we observe, the left and the right hand limit are the same. They are both 5, meaning the limit exists. If for instance that the limit in our left hand side is not the same as the limit in our right hand side, we could conclude that the limit in this condition number 2 is not existing. They must be the same to exist. Now for our third condition, we have to check if the value of f of a in our condition 1 is equal to the limit as we check or calculated in item number 2, which is the second condition. So we could say that f of a is 5 and the limit of f of x as x approaches 1 is equal to 5, meaning the limit exists and it is equal to 5. Now in this example, we have to determine the value of the limit of x plus 1 over 3 as x approaches 5. So number 1 again, the first condition is to check the value of f of a, which is equal to f of 5. Substituting the value of 5, the value of x, which is equal to 5, in our function, it will become 5 plus 1 over 3. And that is going to be 6 over 3, and that is equal to 2. Thus, f of a exists, and that is equal to 2. Now, for the second condition, we have to determine if the limit is existing. So our given function is f of x equal to x plus 1 over 3. And we know that the value of x is approaching 5. Now, as we approach 5 from the positive or right direction, we could possibly have 5.03, 5.02, and 5.01. Now, for the left or negative direction, we could probably have 4.97, 4.98, and 4.99. Now, let's check into what number is our f of x approaching. So we have, that's x plus 1. So we have 4.97 plus 1 over 3. That's 1.99. And then we have 0.97 followed by 4.98 is 1.993. And then our 4.99 is 1.99, let's say 7. Now in our right direction, we have 5.03. That is going to be 2.01. Followed by 5.02 is 2.007. And our 5.01 is 2.003. Now as we observe, the values of our f of x as we go closer to 5 is approaching 2. Yes, it's approaching 2. From the left and going to right, they are both approaching 2. So we could write here that the limit of our f of x as x approaches 5 from the negative direction is equal to 2, and the limit of our f of x as x approaches 5 from a positive direction is equal to 2 also, since the limit in our left and the right side are the same. We could say that the limit exists. The limit exists, and that is equal to 2. Now, to fully say that the limit of a function is existing, we have to satisfy the third condition, that the value of our f of a is equal to the value of the limit. In our first condition, the value of f of a is equal to 2, and in our second condition, the value of our limit is also equal to 2. Now, we could say now or conclude that the limit of x plus 1 over 3 as x approaches 5 is equal to 2. Let me just remind you about some of the theorems of our limit. Number 1, the limit of a constant as x approaches a is equal to the constant. Thus, the limit here of a constant is as x approaches a is equal to c also. Meaning, if we have the limit of 3 as x approaches 5, then the answer is still 3. It is still the constant. Another example, if we have a limit of negative 5 as x approaches 7, that is still equal to negative 5. Number 2, the limit of sum or difference of two or more functions is equal to the sum or difference of their limits. So that the formula is there. As you can see, our limit is being distributed to each term of the given function. So for example, we have the limit of 2x plus 3 as x approaches 1. We could distribute the limit and rewrite it as the limit of 2x as x approaches 1 plus, since this is plus the limit of 3 as x approaches 1. Another example is if we have a limit of 4x squared plus 3x minus 2 as x approaches 3, we could rewrite this as the limit of 4x squared as x approaches 3 plus, since this is plus, the limit of 3x as x approaches 3, and then we have minus here, minus, this is plus on the other, and our second term. So this is going to be minus the limit of 2 as x approaches 3. And now we can evaluate each of our limit to determine the final answer. For our third theorem, the limit of the product of two or more functions is equal to the product of their limits. So we are, instead of addition and subtraction, here in our third theorem, we're talking about product. So for example, we have the limit of 3x as x approaches 5. We could rewrite this as the limit of 3 as x approaches 5 times, since that's multiplication, the limit of x as x approaches 5. Another example, if we have the limit of x squared y, no, let's say for example, five x raised to 3 as x approaches 1, we could rewrite this as the limit of 5 as x approaches 1 times the limit of x cubed as x approaches 1. For our fourth theorem, the limit of the quotient is division, of two or more functions is equal to the quotient of their limits. Example, we have the limit of x plus 1 over 3x minus 2 as x approaches 1. So we could rewrite this as the limit of x plus 1 as x approaches 1 over or divided by the limit of 3x minus 2 as x approaches 1. Another example, we have the limit of 1 minus cosine square x over 3x as x approaches 5. We could rewrite this as the limit of 1 minus cosine square x as x approaches 5 over the limit of 3x as x approaches 5. Then we can now simplify each limit of our numerator and denominator so that we could find the limit of the whole rational function.